So in this video, we're going to review how to sketch a graph of an inequality. And the first thing we want to do when we graph an inequality is we want to graph the boundary. And the boundary is given by the equation if you were to put an equal sign in here. So ultimately what we want to do is we want to graph this. And when I look at the equation that I have here, I notice that it is a parabola. It should open up. And so I'm interested in finding the vertex and the zeros. So the first thing I'm going to do is I'm going to find the vertex, and that is at negative b over 2a. And it looks like the x value of the vertex is 1, or I have an axis of symmetry where x is equal to 1. So I can graph my axis of symmetry. And then to find the y value of the vertex, I would take the 1 and substitute it back into my equation. Like that. So 1 squared is 1. So that's 2 times 1 minus 4. So it looks like the y value of my vertex is at, excuse me, that should be negative 2. At negative 2. So at 1 comma negative 2 is where I'll find my vertex. So I'm going to put that point on the graph. And now I can graph by finding the zeros to fill in the rest of my parabola. I know it's going to open up, so it's going to do something like that. So let's go ahead and find the zeros. I'm going to hop back to the original equation right up here, and I'm going to factor it to find the zeros. So I notice that there is a GCF of 2x in each one of these terms, so I'm going to factor out 2x, and that leaves me with x minus 2 inside my parentheses. If I wanted to double check my factoring, I could just redistribute this 2x. 2x times x is 2x squared, and 2x times negative 2 is negative 4x. So it looks like I factored appropriately. And then I'm going to set each of my factors equal to 0 and find that I have a 0 at 2 and a 0 at 0. So I'm going to put those points on my graph. There is 2 comma 0 and 0 comma 0. And now I want to sketch in my parabola. And remember I said the first thing we do is we graph the equality. Essentially this parabola is the boundary of my inequality. So when I graph it, I need to be careful to observe the inequality symbol right here and notice that this boundary is going to be a dashed line. And the reason it is because there's no equal to underneath my greater than symbol. So when I graph my boundary, I do so with a dashed line. If there had been an equal sign underneath the greater than, I would have made this a solid line, but there wasn't. So I have my dashed line, and now I need to answer the question, do I shade in here or do I shade out here? So in order to answer that question, it's customary to test a point either outside or inside. So I could really test any point I wanted to as long as it wasn't right on the parabola. And I decided to test 1 comma 2. That's this point right here. It's clearly inside the parabola, and if I test that point and I get a true statement, then I know I need to shade inside. If I test that point and I get a false statement, then I would want to shade outside the parabola. So I'm going to go back to the original inequality and plug in 2 for y, and I'm going to substitute 1 for x and sort out this arithmetic and see what I get. So 2 is greater than, let's see, 1 squared is 1, so that's just 2 minus 4. So my statement is 2 is greater than negative 2. 2 is greater than negative 2. And since this is true, then I want to shade in the area where that point exists. Keep in mind, I'm testing 1, 2, and that's true. So my shading is going to happen inside my parabola. And there's the graph of my inequality. So if this had been a linear inequality, I would have followed the same procedures. I would have graphed the line, and then I would have tested a point to determine where to shade. So now, in your review on page 3, you should practice by doing problems 19 through 22.